Hey guys, excuse the quality of the sound. I am recording outside of a coffee shop, but I did test it out. Hopefully, you can hear what I'm saying right now. Alright, so I'm going to talk about number two on test two review. Basically, I'm going to explain to you step by step what I explained to you during lab today, just in case someone needed like a slowed down version of it. Um, because I know some of you guys did go to math chats and stuff, and people did have some problems with this. So I think it's a good decision to make a video. Okay, number two, a truck with 48 inches diameter wheels is traveling 50 miles per hour. So I like to draw um, when I'm given any yes, sorry, doing any word problems because I like to see it in drawings. So it travels 50 miles per hour. That's my speed, right? Lots of noise today. Okay. What you need is this formula here. V equals to omega times radius. V is our linear speed, our velocity, and then omega is your angular speed, and radius is your radius of the circle. Okay. So linear speed would be 50 miles per hour because that's just normal speed that we deal with, right? Omega is something that we are looking for because it says angular speed, right? And the radius, they give you diameter, so I would rewrite that as radius is 48 divided by 2, right, which is 24 inches. All right, notice that this one is in terms of miles per hour. We want the n result here to be radians per minute, so we need to change that. First, I would change the miles per hour. Actually, I'm just gonna rewrite it this way. I'm gonna change this into inches per minute so that we have uniformed units here. 24 inches. So we discussed today that 1 mile is 63,360 inches. So you have to multiply that. I believe you would get 3 million something. Let me put my calculator. That is 3,168,000 inches over hour, right? So that cancels out. So you want that again over minutes, right? So we need to convert this to over minutes. So 1 hour is 60 minutes. So we can cancel these out. So simply divide 3,168,000 divided by 60. That's 52,800 inches per minute. Okay, so that's good. All right. So we established that radius is 24 inches, right? To find omega, is just to divide linear speed divided by radius. So in this case, 52,800 inches per minute divided by 24 inches. And I'm writing it this way so that you guys can see that I'm canceling out the inches here, right? Okay, so I'm going to rewrite that as 52,800 divided by 24. And we have minute on the bottom, and then we have 1, right? Okay, so we want radians per minute. So where does the radians come from? So the best way that I can explain it here is that when we talk about radians, let's say sine pi over 6 is equal to 1/2. We know that, right? So in this equation, pi over 6 has the unit radians, we don't usually write them out. We just assume that everyone knows, like when we talk about pi over 6 or pi, instead of 180 degrees, that's in radians, right? So, what is radians? Um, so, in other words, radians here is a ratio of lengths, right? When we talk about pi over 6. If you pi over 6 here, opposite over hypotenuse, opposite is 1, hypotenuse is 2, right? So, sine of that radians is a ratio of these lengths, right? So where does the radians come from? It would come from this value there. So in other words, you can say, let me simplify 52,800 divided by 24. That's 2,200. That's 2,200 radians over 1 minute. So that's your answer for 2A. Okay? So that's where the radians come from. Alright, for 2B, it's asking how many revolution per minute. And what is that asking? Because we found linear speed, we found angular speed, but we also found radius. What is revolution per minute? Revolution per minute is also angular speed, it's just in a different unit here, right? So what you need to do is to change the unit of that into revolution per minute. So we have radians here to cancel out, and we need to know how many radians in one revolution. One revolution means we just go to the full circle, right? So which is 2 pi radians. Okay, so you cancel out the radians here, and you have left 2,200 times 1. That's 2,200 revolution divided by 2 pi minutes. So you can simplify that. That's 1,100 over pi um, revolution per minute. Or if you want to simplify that, that's about 350 revolution per minute. So that's it. After this, I'm going to talk about how to transform graphs easier. I was at the Cal Central today, and one of your classmates was there, and another tutor showed a trick, and I really think that trick is really helpful, and I wanted to share that with y'all. All right, see y'all then.